Good morning and good evening, everyone. Welcome back. So we started discussing Docker, so image and containerization. And as part of that, we installed Docker and we understood the Docker commands. And these are and Docker file is the declarative way of creating our own images. Okay, so the flow is write Docker file, build image, and push image. Okay, generally this is the one. And Docker run is how to run the image. Okay, so there are only two steps: building the image, okay, and then it means creating the image. This is the steps: creating the image, and you have to inform Docker how to run the image. It means you have to select the options while running the image, like -d, -p, naming the images, and then all these things comes under configuring the image. And just like when you are installing Windows OS to your laptop, you will select a lot of configurations like your username and time zone. So all these comes under configuring the image. So that's the same concept everywhere. First, you build the image. You should have the physical image exist. Once you have the image, then you can play with it. You can configure it however you want. So those are the steps in any image and containerization technology. And as part of this Docker file, so we have, so yesterday we practiced from is the base first instruction. It should be the first instruction to refer the base OS, and then run. Run is the instruction that will be executed at the time of image creation to configure or install packages. And then CMD. CMD is the instruction that will run at the time of container creation. Okay, so that's the main difference between run versus CMD. And let's go to the Docker file reference. So before that, we need to install Docker, right? So I just created one script here, a simple shell script, all how we do this. I'm just running this script to install Docker. So that will install the Docker. Docker file reference. So from run CMD, label is just a key value pair, and expose is to let the user know what are the ports our container is trying to open, and environment, it will give us the configuration key value page so that you can use them in your code. Add is to copy the files from local to the image. Similarly, copy, but add has some two extra things that can directly download the content from internet, and it can directly enter the files to the image. And entry point, yesterday we discussed, entry point is exactly same like CMD, but entry point you cannot override. Okay, so you can use CMD and entry point together so that CMD can supply the default arguments to the entry point, and you can always override the default arguments at the terminal. Okay, so we discussed in detail about that. That is where the CMD command cannot be overridden. Sorry, CMD command can be overridden. Entry point cannot be overridden. So if you can't override entry point, if you try to do, it will go on and apply to the entry points. So this gives an error generally. So CMD and entry point we use basically together in a way that CMD can supply the default arguments and user can always override that through the terminal. So yesterday we have seen that the best example. So yeah, here is fine. So here CMD is supplying the default arguments yahoo.com, but user can always override the CMD. So that's what we say, right? CMD command can be overridden. So these are the instructions we discussed till yesterday. And today, volume is a big concept that we will discuss it separately. And user. From Alma Linux 8. So what is this user is? For example, let me just write this. Run echo hello docker hello dot text. Now let us see with which user this file will be created inside the image. Okay. Right. To cd docker files user docker build -t user v1 dot. So I'm building the image. Docker run. I'm getting the terminal interactive. IT means interactive terminal. User v1 bash. Let's go to the temp. Here, if you see, so this is on the root user because while login itself, you can see we got the root access. What is the problem if you get the root access? Do you think we can give the root access to the container? So is it good? Just you can simply guess. Let us take this server. We have Docker containers. We'll have many Docker containers that may belongs to many projects. Each container belongs to different projects. Ultimately, Docker is using the storage of the VM only. Docker don't have any separate storage. Right? So this is the storage. So this is the storage like hard disk. So if you give root access to the every container it stores data here. Not only container data, entire server data is in the storage, right? In the disk. If one container get the root access, it can get the entire storage access, ideally entire server access. Okay. So we are giving access for the containers to manipulate the data of other containers as well as VM. So that's definitely not a good thing. Okay? And it is not a best practice and it is not allowed also. So that is why we don't allow root access to the Docker images or containers. So this is the question you will get maybe in interviews. How can you restrict, how can you improve the security in Docker containers? And you can say by default, Docker containers will get the root access to the underlying server. So, but we will take care of it. So we will not allow to get the root access by default. That how can you do that with the user instruction? So now the instruction here is, first you need to create the user, like run. I'm creating the user add, for example, Sivakumar. Okay. First the user should be exist. It's good if you have already the existed users in your OS. Okay. Otherwise, we are creating the user, and from next instruction onwards, every instruction should be with this user. Simple. The instruction itself is user. So what will happen from here? Everything will become on the Sivakumar user, not the root access. And once you are logged into the container, also you will not get the root access. Let us see that. Full building it once again because I changed the Docker file. Now you run, take the interactive terminal and then check. Now you can see it's not the root user, and you go inside temp also. So the instruction after that user, everything is based on that particular user you have given. So this is one of the best practice. We will implement this as part of Photoshop again. So that is about the user. And next thing is work tag. So these instructions are very, very simple. Work tags. So yeah, let us take one example again. So first I want to go to the temp directory, and then I want to create some file here. Echo hello docker and then hello.txt. So what is my expectation? I already moved into the temp directory. So the file will be created inside the temp directory. So that is my expectation. Let us see whether that will work or not. Docker build -e work directory :v1 dot. Sorry. Yeah. So let us check Docker run, take the interactive terminal, and then work directory :v1 bash. Okay, I'm inside this. Now, where is my current directory? It is root, but let me go to the temp. I don't have the file I created, but where is it? It is in the root directory only. Hello.txt. Okay. So it means this CD will not work here. So Docker is giving an option. So there is something called work directory that will work like CD. Okay, it will set the working directory, current working directory. So now instead of this one, what I have to give, work directory /temp. So now the every instruction will run inside this directory. Okay, it's a simple thing. Instead of CD, Docker is giving us just work directory. Now let's go and then check git pull docker build -t and docker run. You can see by default you are landed inside the temp directory. That is because you set the work directory. Now you can check it is already inside the temp. So this is how the work directory instruction is useful. And the next instruction is arg. So arg is generally has some concept around it. It will supply variables at the build time. So just like shell scripting, so we can pass variables to shell scripting. For example, something mail.sh, you can pass to email, you can pass subject line. So this is the arguments you are passing. So this will be in $1, this will be in $2, right? Similarly, you can supply some variables to the Docker at the build time. Okay, remember this, at the build time only. Org instruction will only work at the build time, not at the container. Okay, we'll see this now. Arg Docker file. So now the concept here is we have CentOS 7, 8, and 9 versions. Okay, like Alma Linux, we have multiple versions, 7, 8, and 9. So maybe you started creating image on Alma Linux 7, and maybe after few days, after few months, you got the latest version in the market, that is 8. So how can you control this through the variables without changing the Docker file? I want to do this through variables. So that's the variable concept. What variable concept always tell us, without disturbing the existing code, you can always change the variables so that your code can work with the latest configuration or latest things. Okay, so that's what every variable concept tell us. Okay, so Arc has one more important point. So that is what I said about from. What is the condition of from? It should be the first instruction, right? But there is only one exception. The exception is R can be the first instruction to supply the OS version to from instruction. So in one exceptional case, R can be the first instruction, so that can supply the version to the OS. So let us see how that happens. Generally, we will hard code Alma Linux 8, right? So, but what happens when the 9 releases? You have to come here and change it again. So without disturbing the code, I want to do it from the variables, that is through the R. Okay, just tell the version. Okay, so this is the variable version. Version is the variable. Okay, so instead of hard coding here, you can refer it, that is dollar version. Okay, and remember this variable before from will not work after from. Arg variable before from will not work after from. So this has access only till the from instruction. If you try to refer this in the further instruction, you will not get it. Okay, let us check that. Run echo version passed by user is this. Okay. So I'm passing the version, okay, for the Alma Linux. And then, as I said, arg variable before from instruction will not work after from. So it has access till here only. Let us check this as well. Okay. Mm, Docker build hyphen t r colon v1 dot. There is some error. Okay. So what is this error here is with the point is not here in the Docker. Okay. So what is the error here is, so Docker base OS is very important and I'm not passing the variable. So that is the error. So if you are not passing the variable, what is the OS Docker should fetch? So that is the error. So obviously you must pass variable build arg version equal to 9. Okay, you can see we got Alma Linux 9. And now you can check the version is not printed, even you passed 9. So as I said, it has access only till the from instruction. You can pass version 8 also. Now you can see we got the version 8. So what if I forget? So obviously I get an error. So it's our responsibility if user forgets. So we will tell to use a default version that is 8. So the syntax is like this. You can check the reference here. This is the one. If user forgets to pass the variable for this, you can always give some default value. That is like this. Okay. Now let me check it. Now I'm not passing. I should not get an error because I said if user is not passing, take the default value of 8. Okay, so this is the arg generally. You can use other variable also, arg course, arg trainer. Okay. So you can use them inside the course is dollar course trainer is dollar train. So you can use arguments like this. These are the variables and I have to supply the values. So I need to give values hyphen build r course equal to DevOps trainer equal to 0, something like this. So here I forgot to give again. So every R you have to give like this. Okay. build arc. Now you can see you are able to print. So this is about the arc. But remember one point, there is a popular interview question that is arc versus ENV. Okay, so the difference. Arc variable only work in build time, but ENV variables can work in build as well as runtime. Okay, runtime is nothing but container. Remember this, build is image, running is container. Okay, so now let us try to check whether we get the access or not. Docker run -it r colon v1 bash. Now you check env variable. So you don't have the arg variables here. So this point is clear. Arg will only work in the build time. Again, interviewer will ask, but I want to use arg variables in the container also. What is the way you can follow? So there is a simple hack for that. Let me check this here. Simple solution is like this. Okay. So what we do here now is what Docker is saying. If you want arg values to access inside the container also, create env variables force equal to, and then pass the values like this. Dollar course. So what I'm doing here, I'm getting the value of this and I'm giving the supplying to the env variable. Trainer equal to dollar train. Okay, very simple. You create env variable and pass the value of arg to the env variable so that it can be accessed within the container also. Okay, let us check this. The Docker run or bash. Now you can check env. So you got the variables. So this is the popular env versus arg. So as I said, there are few interview questions, that is arg versus env, run versus cmd. Explain as a professional, don't explain as a reader from internet. Okay, so whatever we did till now, that is to the professional experience, that is to the complete understanding the concept and explaining. So usually candidates read from the internet and they don't know what they are explaining also. Maybe they by heart or they read CMD versus entry point and add versus copy. So these are the very, very popular. We'll definitely face question from this. And the next instruction we have is on build. So on build instruction. So generally the concept here is on build. We are developing Docker images. Docker images. Someone else may use our images. And that's what we are doing. We are getting the images from the internet through the docker.io. So I am pushing my image. Like yesterday, I pushed uh, some image, right? You can use that image. I pushed this image. This is a public image. Okay, you can use this image generally. So while you are using, I want to give some, I want something to, I want you to follow something that is like, as a image developer, I need to make some rules. So how can you create those rules is through on-build instruction. So that let us see. On-build Docker file. So we are developing engines, right? So just imagine, so within my organization, I'm using the Nginx image. Okay, so this is the one. So once you install Nginx, generally what are we doing? We are removing the default index.html, right? So we don't want index.html, and then we are running. But if you run this, what will happen? You cannot see anything in the internet since you removed the welcome page. This is the welcome page. So now what I want, I will write on build instruction and then add index.html to this folder. So on build instruction will not execute at the time of image. On build instruction will not execute at the time of image built by developer. Okay. So then when it will execute, on build will execute at the time of someone use your image. Okay. So let us see this. I am publishing Nginx image to repository. Okay. All my projects have to use this Nginx image. Okay. So as an image developer, what I said, you should have index.html in your workspace to use this on build image. Let us see that now. Okay. So now let me pull it. Cd on build docker build -t on build :v1 dot. Okay, so it got executed without any error. So do you think this got executed at the time of image? because I don't have index.html. If this had executed, I should get an error. Yes or no? Can you please respond in the chat? Yes. So this was not executed when the image developer is building his image. Then when it will get executed, now let us see. Okay. So we have the image exists on build v1. Now I'm just creating a directory on build test, on build test, and here I'm writing some Docker file from on build colon v1. Okay, I'm just trying to use this. Now let us see whether this will be success or not. Docker build test colon v1 hyphen t. Sorry. So what it is saying. So this got executed and it is giving an error. You don't have index.html. So if someone tries to use your image, your on-build instructions will work. So as an image developer, you can write any number of like many on-build instructions to force your image users to follow something. Okay. So now I'm forcing my user, they should have index.html in their workspace. Okay. So now echo hello from on build. Okay. Index.html. So now I have index.html. Now if you run docker build, so that got success. Okay. This is what the on build instruction. Stop signal, there is nothing to discuss. It is by default. No need to use in our daily project also. Health check, we will discuss this as part of Kubernetes. Okay. So there it is more useful. In Docker, it's not useful. So these are the instructions we use in our Docker and then while developing the images. Okay. So mostly half of them we use. So enough by understanding the instructions. We almost understood everything. Now let us configure our RoboShop as Docker containers. RoboShop Docker. Okay. Create RoboShop Docker. Let's take 5 minutes break then. Anyhow, this is a new concept, right? So we'll come back at 7:57. Okay, 5 minutes break. Okay, so we are back. So till now we understood Docker commands and then Docker file instructions. Now we can configure our RoboShop project using Docker images and then containers. Okay. So just remember every time only one thing, Docker or any image and containerization concept is image and then how to run image. That is nothing but container. Okay. So image is a physical that has some memory. How to run image is nothing but configuring. So now, so let us first configure our web so that we can see something on the internet. So I'm creating web folder. So where is our, so we need code to web. So where is our code? And just check RoboShop GitHub. Okay. So this is the code app we are using it. Okay. So this is the GitHub open source of RoboShop. There are a lot of contributors, around 25 contributors across the world, and it is from the IBM. The code is here, web, and then we got the catalog code that is nothing but this one. And you can download it from our documentation also. So it is downloaded, and you can see this is the code. You can get the same code from the official RoboShop web also. Okay, here you can check the static. This is the one. The same code, we have it here. So now what I'm doing here, RoboShop Docker web. So here I'm creating one folder called static. It means the static content is going to be here. Okay. And then Photoshop Docker web static. So this is our web interface code. I'm just keeping it here. That's it. Okay. And now I need to create obviously Docker file. Docker file. Oh, it's not a folder. Inside web, I need to create a file that is Docker file. So what will you suggest? You want me to take the Alma Linux and install Nginx, or you want me to use the Nginx from directly? Which one you suggest? Can someone please respond in the chat? Which one is good? We build our own Nginx, or we will get it from the already developed image of Nginx? So generally our concentration is on web. No need to concentrate again on developing the Nginx image. If you do that, there is something, some security patch or something, we have to manage our own. if we try to develop everything on our own, we are responsible to manage it also. But if you refer that from the official Nginx Docker Hub, then obviously we are not the maintainers. We don't need to take care of the maintenance. Okay. So it's always good if someone have, just like when you are constructing home, so we don't prepare our own bricks. We don't manufacture. We will get it from the persons who already manufactured it. Similarly, try to, and we are using official image also. Nginx, if I get this, Nginx, I'm using official image. If you don't have official image, then you can use your own because we simply cannot trust everyone else in the internet. So if you have official image available, then use it. That is the recommendation. So I'm going to use from Nginx. Now I no need to create instructions, install Nginx, and then no need to configure, no need to run. Everything is inside the image only. And then now I want to remove the default HTML. Share Nginx slash HTML slash index.html. Okay. And we should have the Nginx configuration also, right? Our RoboShop configuration. So where is it? This is our RoboShop. RoboShop.conf. Okay. So here I'm just doing it localhost temporary. Okay. We'll change it later. Okay, so this is the configuration for our reverse proxy, and this is the code, and we are writing Dockerfile. I removed it. Now I need to copy our configuration. So generally, how where we copy? So we will copy to the etc nginx default.d direct. So now I'm copying roboshop.conf, roboshop.conf to this directory. Okay. And similarly, I need to copy the code also. Add static and then USR share nginx HTML directory. Why I'm using add and copy both? Because just I want to mention both are doing the same job here. Okay. So I'm getting everything inside static folder into the HTML folder. That's what I'm copying. Okay. And else. So that's it actually. I removed the default default index.html and I copied our reverse proxy configuration and I copied our code. Now let us try this. VG Photoshop Docker. git init, git remote, add origin, pushing it. Okay. So once you have the code available, let us pull this, git clone, cd roboshop docker web, docker build -t web v1 dot. Okay, it's done. Now image building is done. Docker images. So we have the image available of 188 MB size. Okay. Docker run. I want to run in detach mode -p 80:80 and then --name. I'm naming it as web and web v1. That's it. Okay. So running the image web v1. You can give the image like this, or you can give the image ID also. And I'm naming the container as web, and I'm exposing the port number 80 to the outside world and running in a detached mode. Now let us see Docker PS. So it is running. Let me open this IP address. Yes, my RoboShop is, I'm able to open my RoboShop. Okay. So this is very simple. You are not doing it, not doing any installations within seconds. Just understand the difference between documentation. You can see the number of steps here. First, you need to create the server, install Nginx, enable Nginx, start Nginx, and then download this and unzipping, doing the conf. So some steps are same, like copying the configuration, everything. So there are many steps here. So at any point of time, if you want another instance, again, you have to do everything. But here you can see it is very simple. There is already a developed Nginx image fully configured. You just need to remove that index.html and then copy your configuration, copy your code, then you will get the application up and running. Okay. So let us work on our catalog and then MongoDB also. So now first let us work on catalog. I'm creating another folder, catalog. So obviously we should have Docker file, and then you should have the code also. Let me take the code. The code is nothing but package.json and server.js. And copying here package.json and server.js. Now I need to write the Docker file. So again, here we no need to do the everything. Like what is it? Installing Node.js and then this one. So installing Node.js and many steps we no need to do. So we'll check how can we do that. Okay. So first I need Node.js image. Let us try to get that. Node.js. This is Node. Okay, so Node is the official image. So you can see many versions here. 20 version, 18 version, 14 version. Okay. So let us try to use 14 because this was developed in 14. It will work in 18 also. 18 is the latest table. So let me take the 14, just published 7 months ago. Node 14. So what you can expect from this node, the Node.js environment is installed already. Okay. So what is the port number our application is using? You remember? Please type in the chat. What is the port number of catalog application is trying to open? All our applications in the app tier is opening port number 8080. So I'm just mentioning this. Okay. And then work directory, I'm setting it up like opt and server. So inside this, there will be a folder created inside opt, that is server. Okay. And we are creating the user, right? RoboShop user or whatever, you have to create some user. That is that is so we don't know which OS it is. If you want to check Docker run -it node:14. So user add creation of user is different in different OS. For example, it is add user in CentOS and user add in Ubuntu. So we just want to understand what is the OS it is. Docker run -it node:14 and bash. At etc star release. If you type, you can see the OS is Debian. So Debian is nothing but one of the Ubuntu version. So in images and containers, you don't care about the underlying OS, just one command may change. So that is, you can refer it from here. That is catalog. If they have mentioned Docker file. First, let us follow this directly and then the user creation, all these things. Let me take another session on implementing best standards. So exposing work directory setup and copy the package.json. So from next instruction, everything will be copied inside opt server. Copy package.json. Obviously, the current directory opt server, and then copy server.js also. You can just give dot because we are already inside opt.server, and then you can run npm install, and then finally the command node server.js. Okay, that's it. You're already in node environment. I'm exposing, just creating one dedicated directory for our application and then copying the package.json, server.js, npm install will install the dependencies and server.js. Okay. So no worries. Actually, I will also remove these steps, installing all these things. I will do it from the CI. Okay, Jenkins. I will do everything from the CI. This will become even more simple. But first we need to understand, and after that I will move this part to the Jenkins CI. Okay. Now let us push. Exit, and then git pull cd catalog docker build -p catalog v1 dot. Okay, catalog is built. Now docker build, sorry, docker run. I docker run in detach mode, and then. So do you think we need to give the catalog access to the open internet? So is user opening catalog directly? No. So it is through the reverse proxy. We no need to provide, we no need to expose the catalog application to the outside world through the port forwarding. We don't need that. Okay. So I'm not giving -p that one, and hyphen name catalog I am giving, and the image name catalog v1 catalog. Now docker ps. Let us see. It got exited. Let us check the error. Docker logs. So there is an error. MongoDB error. Because MongoDB is not exist here, obviously we are getting an error. So it requires MongoDB, right? So I need to have MongoDB also running. So let us create our MongoDB. MongoDB Docker file. So MongoDB is very simple. You just need to get the MongoDB image itself. That is obviously installed with everything. Okay, Mongo 5, and then. So you know, right, we need to load the categories data. So we have this catalog.js and then user.js. Okay, just creating catalog.js. So this is the categories data, and then user.js. So this is the user data. You can refer our repos while you are practicing. So what this MongoDB image is telling us, let us go and then check. Whenever you are creating MongoDB, okay, through this image, and if you read the documentation here, there is something in it. Mongo initdb database. Okay, so this one, if you keep any .js files in a particular directory, MongoDB by default load the data. So it is that much simple. So that's what these guys are using it. You can just check here. You can keep your .js files into that location. Then by default, your MongoDB will load it. This configuration is even more simple. Okay, so that's what this paragraph generally says. If you keep some JS files into this directory, I will load the data into the MongoDB database automatically. Okay, this is that much simple. Git pull cd MongoDB clear, and then docker build -t MongoDB v1 dot. Okay, that is done. Now you can just docker run -t. Again, I don't need to expose this to the open internet. I'm not giving -p. I'm just giving MongoDB as name and MongoDB v1. That's it. Now docker ps, where MongoDB is running, and just check the logs, docker logs, and you can see waiting for connections. So everything is done. Now it is waiting for connections. Now let us run our catalog. The container name catalog is already in use. Docker rm-f catalog, because it's already exists. Now you can check docker ps, still not running docker ps-a. Why? Because it is not able to connect MongoDB. Why is it not able to connect? This is some concept around here, networking. So let us discuss that. So this is our home internet. We got a modem here. And you have a laptop. And you have a mobile. And maybe you have refrigerators, Alexa, everything is connected to internet. That is through the Wi-Fi or TV. So all these things are connected to internet through Wi-Fi, right? So who will give IP address? Obviously, our modem has to give IP address. Now let me take my laptop here. IP config. Now you can see this is the Wi-Fi adapter, and the default gateway is this one. This is my modem IP address. Okay. And my laptop IP address is this one, 0.110. Similarly, my mobile like 0.2 or 0.3, and our TV like 0.5, 0.6 like that. So this is the default one. This, whatever the device you connect to your home Wi-Fi, so this modem will allocate the IP address to you. Similarly, in Docker also, there are two types of networking. Docker networking. One is host networking and the other one is bridge networking. Okay, host networking, let us see that later. Now let us discuss on bridge networking. That is the default networking mode here. Okay, so what is this bridge networking? Let me check here. IP. Oh, IP. What are the options? I want all the details. Right from here. IF config. Okay. So now if you see here, so this is the connection from my AWS IP, AWS, right? Let me take this. So this is our AWS VM, and it got connected to AWS ISP, AWS Internet Service Provider. So my system got IP address through the AWS ISP. Okay, so that is this one, Ethernet interface. So this is connected to the Ethernet actually. So not modem, generally Ethernet, because it is in that data center, AWS data center. Right, this is Ethernet interface. And you can see we have another one, that is Docker Zero interface. So what is this Docker Zero interface? This is the Docker network within the server, not outside. Okay. For example, this is the Docker Zero. Okay. So whenever you launch containers, okay, whenever you launch containers generally, so where are you getting IP address? The IP address is from Docker Zero. Okay. Your Docker containers will get IP address from Docker interface, whatever the container you launch. Now let us check it. So we have already two containers running, Docker PS, and let me get the container ID, Docker inspect, and then grep IP. Apply grep IP. Now you can see the IP address is this one, 172 dot for which container it is, Docker PS, Docker PS 83P. This is for MongoDB. The IP address is this one, MongoDB. This is the IP address. Similarly, let's get the IP address for our web also. Docker inspect container ID. I'm grepping for IP. And this one, 0.2. Now you can see. So this is the 172.17.0.1. Okay. This is our Docker interface. So this is the modem actually. You can just consider it as modem. So this is giving the IP address within its range 172.17.0.20.3. So it is giving the IP address within its range. Now I want these containers to communicate with each other. I want these containers to communicate with each other. So one problem here in the default bridge network is disadvantage of default Docker bridge. You can't communicate containers with names. Okay, do you think IP address will be stable or it will keep on change? Please answer in the chat. So do you think your IP address is permanent or it will change? So even your laptop IP address also, it will be keep on changing by your modem. So it's not permanent. So we cannot depend on the IP address for communication. So we have to depend on the DNS. That's what we are using Route 53. So here I want the containers to communicate with their names. But in the disadvantages of Docker default network, you cannot communicate with the DNS. So you need to create your own network. So that is very simple. Docker network. You just check -help. So we have the commands Docker network create RoboShop. Okay, so you got the network created. Docker network, you can just check ls. Okay, we have the RoboShop, and by default it is bridge network. Okay, till now we are using this one, but from now we are going to use RoboShop bridge network. Now if you check if config, now you can see another network, that is this one. You can see bridge 746A 76764A. This is the bridge network. Now the IP address you will get in this range 172.18.0. This one. So now bridge network is not, default bridge network will not work. So this is our RoboShop network. Now what I do, I will remove the containers first. Docker remove -f, Docker ps -a and q. Okay, I remove the containers. Now I am running Docker run -d -name MongoDB -network something. Docker network command network option. Just -network equal to your network name. -network equal to RoboShop, and the image is MongoDB :v1. So that's it. Now instead of launching into the default bridge network, I am launching it into the RoboShop network. Now Docker ps. Now you can check Docker inspect, and then let us grab for IP address. Now you can see. So this is the RoboShop network range. Okay. Now similarly, let us launch our catalog also. -network RoboShop. equal to, you have to mention equal to. RoboShop. So now I'm launching catalog into RoboShop. Now let us see. Still not running. Oh, the error here, Docker logs. Hmm, Something wrong in the code because I'm directly using the code. So let me make as per the code actually. So we need to set one variable to true. So that is through our documentation also. So here Mongo true. So I can make the environment variable here. So within that Docker file, I'm just making env Mongo equal to true. That's it. Okay. So it is expecting that variable. Now let me push full catalog. You don't need to worry about this. Okay. This is purely development related. You will get it. Catalog v1 dot. Oh, shit. Now you run this. Docker remove -f catalog. Docker ps. Okay, now it is running. Let us check Docker logs container. You can see MongoDB is connected, right? And the name is, let me just log in, Docker run, sorry, Docker exec. It's already running. If it is running container, then you have to give exec. Docker exec -it catalog bash. Now I'm just pinging MongoDB. I'm getting response because I'm able to connect other containers in our own network with names, just MongoDB. Okay. So this is web. This is catalog. This is MongoDB. So you can just check here in our code, either you give the Mongo URL as environment variable or otherwise it is connecting to the, you can see MongoDB. Host name itself is MongoDB, right? So this is, you should just do a postmortem of this. So this is protocol. colon host name or IP address colon port number slash schema. Okay, here MongoDB is the host name. You are able to communicate within the network. You can see I'm able to communicate. So now let us configure our web also. So here inside the configuration catalog, I just want to mention name of my container catalog. That's it. Catalog 8080 because catalog is already run. So since I changed something, let me push. I need to rebuild Docker build -t web v1 dot. I built it. Now Docker run -d -p 80 and then -name web -network equal to RoboShop and then web v1. Okay. Now Docker ps. Just log in inside the container. Docker exec -it bash ping catalog. So ping command not found in this. So just Debian install ping. So that is IP utils ping. Just you need to install this command. For troubleshooting generally. Okay. Then you need to update. Install. Now ping catalog. Okay, now you can see we are getting the response. So it means it is connected. Now if you just open or refresh this, okay, not getting, let us just do the inspect. It's no refresh. Let me troubleshoot from here. I'm inside web. Let us go to etc nginx default.t ls-l cat roboshop.conf. It is calling 8080 on /API/catalog and let me get it. HTTP catalog :8080/help. Okay, we are getting it, and then /categories. We are getting those categories as well. But in the browser, image.html categories. Can you try this from your mobiles? Actual request itself is not going. No, yeah. So now it is going slash API slash is saying 404 not found. So now let us search the logs. Docker logs web. I'm getting 404. So there is something wrong in the configuration. Something wrong in the configuration. What is it? Again, troubleshoot localhost. We're getting the request as API catalog slash categories. There is something wrong in the reverse proxy configuration. Strong here. This is going to the localhost on port number 8 and then sending the request here that we just hit with catalog 8080. We are getting it. The reverse proxy is not working here. Color is different. Let us check. Some color is different. Cat, etc. Nginx, default.t, Photoshop.configuration. This seems correct to me. It is including only conf.t, not default.t directly. So we can just change this into conf.t. Okay, so you can see this is including, it is getting the configurations from. Generally, we should have another default.t also. You just see Nginx sample configuration. include directory. So few configurations they will include, few configurations they will not include. So here it is including only conf.d directory. So let me keep the configuration in conf.d. It pull Docker build and then Docker run. Docker remove -f web. Okay, now let us check. Not even running. Docker ps. Docker ps-j. Docker logs. Is not allowing this file. Let us do one thing. I faced this problem also earlier. Let me get it from the previous batch. So this is the full configuration. So images obviously sometimes we face some problems, but we need to adjust according to that. So this is the full configuration, not just RoboShop, everything. Okay. Let me remove this because these are not exist now. This is the full configuration. Before that, I need to remove the existing configuration. Remove the default existing configurations and then just name it as Nginx configuration in Nginx directory itself. Okay, that's it. Now this will work. So what I did is instead of keeping the separate reverse proxy, I'm just mentioning it as in this location. Docker build, Docker remove -get web. Sorry, we will complete and end this session. Just 5 more minutes max. Docker ps. Now it seems running. It's okay. Now you are able to load the categories. Why images are not getting? Reference. It's okay, we can stop till here. There is some problem with images. Why? We'll see that. Maybe in the Nginx configuration. Oh, we are getting some images. Okay, it's fine. We'll see this. Any questions? Sri Hari? Can unmute and ask Sri Hari. Any other questions from anyone? Any other questions from anyone? So practice this Docker file instruction. Someone please prepare a documentation on entire Docker file instructions and the popular the interview questions, as I said, and start configuring our Docker shop also. No questions, we can end the session. Have a nice day. See you tomorrow. Bye-bye. Okay, Sharon, you have some question?
Yeah, Shiva. Actually, initially we were talking about container could be on the VM2, right?
Yeah, it is in VM only.
So when we say VM, there would be many guest OS, and inside those guest OS, we would be, there would be a Docker architecture installed in it.
So this is VM, right? Whatever we got here, that is VM.
Okay, so
what is this server from AWS? This is VM only.
That is a VM.
So underlying AWS has a very big physical hardware. So out of that hardware, they are giving us one VM.
Okay, so VM has multiple OS, and it could be. I think I'm thinking in a different viewpoint.
Yeah, understood. So this is AWS hardware. Okay, we are not sure. And whenever you request, AWS is giving us VM. So AWS hardware definitely have some host OS.
Okay.
Okay. And this is our guest OS. We selected this. So according to AWS, this is our guest OS. Okay, so that is CentOS 8.
Yes.
Right. So inside this, we already installed Docker.
Are you sharing the screen?
Yes.
Sorry, I couldn't see it.
Sorry. I was almost ending the session. Yeah. So this is Docker. So don't worry about AWS hardware and don't think you are in guest OS, something like that. Okay. So now you got Docker. On top of Docker, you are installing the containers. Right? What is the host OS? Just remove this. What is the host OS here?
CentOS.
CentOS. And what is the guest OS? It's your wish. From image. Right?
Oh, okay. Okay. Yep. Thank you.
Sri Hari. Okay, if no questions, see you in tomorrow session. Bye-bye.